This has been the substitution rule for indefinite integrals. Indefinite integrals where we don't specify any lower and upper bounds, and that our answers are going to look like some function plus c. But we can do the same kind of thing when it comes to definite integrals. So what I want to consider here is the integral from a to b of the same kind of integrand, f of g times g prime. And I want to figure out what can I do in that scenario. Well, first of all, it's the same basic idea that we had before, the antiderivative of f, the capital F, at g, but evaluated between a and b. And these bars mean I'm going to plug in b and I'm going to subtract off plugging in a. So in other words, this just looks like f of g of b minus f of g of a. However, I can manipulate this. I know what this is. I can write it in terms of u in the following way. This is going to be the definite integral between g of a and g of b, where I take the little f evaluated at u du. In other words, when I think about it in terms of this way, we're using our sort of variable of integration as this u. When I think of it originally, the variable of integration is going to be x. And that when you change these formats, you also have to change the limits of integration. This says x equals a to x equal to b. But down here, this says u equals g of a up to u equals g of b. And that should make sense since u was defined to be g of x. When x was a, then u should be g of a. So now we have this nice formula. Let's put it all together. We have that the definite integral from a to b of functions of this form are the integral from g of a to g of b of f of u du. So how does this work out in an example? Let's take the integral from 0 to 1 of the square root of 1 plus 3x dx. So the first thing is, got to figure out what's our u and what's going to be our function. So I think that our u here is this part underneath the square root. We always can sort of have a bit of a hint at this because we can think f of g of x is a composition. And here I have a composition as well, square root of 1 plus 3x. So I'm going to set that to be my u. Now that I've identified the u, I want to go to, how about the g of a and the g of b? Well, u equals g of x is equal to 1 plus 3x. So if I plug in 0 here, then what I'm going to get is just 1 plus 0. So g of 0 is 1. And if I plug in the 1 for my x, I get 1 plus 3, which is equal to 4. So that's what my bounds are going to be. They're going between now 1 and 4. And then I have to think about what's my du. The derivative of my g, the derivative of my 1 plus 3x is 3. So my du should be 3 dx. Now, the only problem is there's not actually a 3 on the outside. So I want there to be a 3 on the outside. I'm going to do that same trick. I'm going to multiply the top and multiply the bottom by 3. And what this is going to give me is going to give me 1/3, and then the 3 dx combines into being a du. So it's 1/3 du, square root of u, we know that part, and the 1 and 4 is what the 0 and 1 have changed to when I've exchanged it from expressing it in terms of x to expressing it in terms of u. And now this is an integral that we know how to do. This is just going to be some power. We can compute that. This is u to the 1/2. U to the 1/2's antiderivative is u to the 3/2 times 2/3. And so what I'm going to therefore get is the 1/3 comes all the way out the front. And then the u to the 1/2 becomes this 2/3 u to the 3/2. And I'm evaluating it between 1 and 4. By the way, since taking derivatives is usually a little bit easier for us at the beginning, it's always good to do this quick check. If I take the derivative of u to the 3/2, it would be the 3/2 comes out the front, cancels with the 2/3, and goes to u to the 3/2 minus 1, which is the square root. So if you ever sort of forget these formulas, take what you're guessing and take its derivative and verify that it really is an antiderivative. Nonetheless, the final step that is remaining for us is to evaluate the 4 and the 1, so I'm just going to plug them in. I can say this is the 1/3 times the 2/3 is the 2/9. So I get my 2/9 here. And then it's just the 4 to the 3/2 minus the 1 to the 3/2. I can say 4 to the 3/2 is like 2 cubed, which is 2, 4, 8. 8 minus 1 is 7. And so I get, in the end, 14/9.